Hello, this is the video for the limits, and there's a total of approximately, not approximately, there are four questions in total for this one. I got the questions from one of my students, and we're going to just go over how to deal with the limits when it's approaching specifically to infinity or negative infinity for that matter. And it's not that difficult in terms of how to figure it out because you'll be disregarding most of the stuff on the questions, and what you need to realize is that you need to be able to read it without the complicated mess behind it. It's very, very short and concise if you understand how to take the shortcuts and the logic behind it in order to solve these problems. So let's get right into it here. Unfortunately, the questions I've received, because they were such a small, like small in terms of the file size or the font size. That's why I had to rewrite it handwritten like this, but it's still not going to make that much of a big difference. All right, so for example, this question here, it says that I need to do two parts. Limit as x approaches infinity for the first one, and as limit as x approaches negative infinity for the second one. Now, whenever you're given these questions, these are called rational functions because rational functions means it's the same thing as saying fraction functions. Okay, so whenever you see rational, I want you to think of fractions, and you can see how it's a fraction. Like you have something over something, like a circle over a triangle, right? Whenever you're given a limit question in a rational function situation, I can't like zoom out. Okay, so what you always want to take a look at is the leading term. This is the crucial part for all these questions is that you only have to be looking at the leading term and its coefficient. That's really the most important thing that you have to remember for these types of questions. So what do I mean by that? Well, most of the cases, it turns out that it's the very first term from the top and the bottom. So you want to be looking at the leading term and coefficient of both numerator and the denominator, of course. And then you're only going to focus on just that because the limit is infinity. If you guys were to plug in, that just simply means to plug in, essentially, an infinity into the x's here and here. Okay? But then what about the x's here and here? Well, if you guys were to plug in infinity, which is a very, very big number, okay? So let me just write down everything laid out here. So what I did was I took the equation and I plugged in infinity for wherever there was an x in it, right? So if you ever see that wherever the x is, I'm just simply going to plug in the infinity in there. So when you plug in the infinity, you have to understand what happens. What happens essentially is that this cubic function here, that will take care of the entire problem for you because even if you square it or if you raise it to the first power, essentially all of this is so insignificant to this x to the power of 3 that it's actually negligible.
Hello, Mr. Kim, Mr. Altali.
Because if you plug in a very, very big number, x cubed is so much greater than x squared, and that's so much greater than x that eventually, oh, I have to, okay, eventually, when you guys plug this in, it just serves absolutely, oh, I have to probably in this call. Okay, it just absolutely has nothing to do with the question itself. So you guys can disregard everything that has power that is less than 3. Everything. Okay? That is so much less than power of 3. So all of this, you're just going to say, you know what? I'm not even going to care about that. That's complete garbage. It's trash. So here, you're only taking a look at x cubed for the first one because this plus 7 is trash. And this x cubed is the only one that's going to look at because that's your leading term and coefficient. So all of this is trash. So you're going to be taking a look at just those two. And when you guys take a look at these two and say, okay, now if I plug in an infinity here, okay, now we're talking about the numbers that's in the same zone, like x cubed and x cubed, right? So 2 positive infinity cubed, positive infinity cubed. What do you think is going to happen to these two guys right here? They're going to cancel out. So the limit, essentially, it becomes just 2. And that's it. Okay, so the limit as x approaches positive infinity, the answer for part A would be just simply be 2. Now for the second one, part B, it's going to be essentially the same question. So I'm going to skip all of this part where you would consider everything to be trash, and I'm going to put negative infinity instead of positive infinity, just like that one. And notice what happens is that this negative infinity cubed and this negative infinity cubed in the bottom, they will exactly the same, so they cancel each other out again. And what does it make? It makes it a positive one. Because a negative divided by negative still makes it a positive, right? So believe it or not, that also limit becomes a 2. So part B also becomes a 2. Okay? Alright, so let's try the second question. Let's do part A and part B. Limit as x approaches positive infinity and limit as x approaches negative infinity. Now, as before, you're only going to consider the highest degree or the leading term for both top and the bottom for numerator and denominator, which means this plus 7, okay, after you plug in the infinity here, this plus 7 does nothing to the infinity because it's so small. Get rid of it. Minus 2, forget it. Completely garbage. It's trash. So what I'm left with is 3x over x squared. Okay? Now I can cancel out one of the x's because we have the same number on top and bottom, so it's 3 over x, and that's what you're going to be dealing with here. So now what you're going to do is now you're going to plug in x as infinity into the function here and see what you're going to end up with. If you guys type in 3 divided by infinity, now obviously you can't type in infinity into the calculator, but what infinity represents is a very, very big number. Suppose you go to your calculator and type in 3 divided by, I don't know, 1 billion. You're going to get 0.0000 like that, right? So what that shows us is that as this number grows, this number, this entire 3 divided by infinity actually ends up landing you to become 0 because it's 0.000000 whatever that may be, but that's close to being 0. So the limit as x approaches infinity will be a 0. Now in this case, I'm going to borrow this because that's our simplified format of this equation where we get rid of all the trash out the way. Now if I plug in a negative infinity here, what is it going to give you? Well, if it's 3 divided by negative infinity, well negative infinity is like negative billion, right? Well, that's going to give you negative 0.000000 something. Well, that's still being very, very close to being what we call essentially 0. Because 3 divided by a very big number or a very big negative number, like this one, a very big negative number will still land you somewhere close to being 0. There's not a such thing as a negative 0, right? So we don't do that. We just say it's just 0. 0 is neutral. It's absence of signs. Okay, so that's your second problem. Your third problem here. Again, what's your first step? That's the only thing I'm going to care about. The rest of it is garbage. Throw them out in the trash. Part A, as limit as x approaches positive infinity, means 9x to the fourth power over 2x to the fourth power. And part B is limit as x approaches negative infinity, 9x to the fourth power, 2x to the fourth power. Do you guys notice anything that you can do here? Yes, the x fourth will cancel each other out. So what am I going to end up with is that as x approaches positive infinity, it's 9 over 2. Limit as x approaches negative infinity is 9 over 2. Well, there is no x's whatsoever, right? So the limit actually just becomes 9 over 2 because the x to the fourth power will just cancel each other out. After you plug in infinity, it will still cancel each other out. After you plug in negative infinity, it will still cancel each other out. So there is no point. So the limit is just simply 9 over 2 for the third question. Now for the last question, it just gives you that limit as x approaches positive infinity. So that's the only thing that we're going to do. Here it's a little bit tricky because now what we have is this a square root symbol. We call this radical, right? So we have this radical symbol here, but that doesn't really change anything because you're still going to take a look at what we consider to be the leading term. Now here, if you take a look, x minus 3 over square root of 4x squared plus 25. Now I can see some of you guys might be going, okay, if I do square root of 4x squared, it's 2x, square root of 25 is plus 5. Please do not do that. That's not what this is talking about. And quite frankly, we're not allowed to do that here because you can only do that if it's like this, 2x plus 5 squared. If this entire thing was squared and then square rooted, then yes, the squared and the square would cancel each other out, but this is 4x squared plus 25. Square rooting that is different from square rooting this because this is foiling it. Okay, 2x plus 5 times another 2x plus 5, that should give you 4x squared plus 20x plus 25. That and that is two complete different things. So you don't want to do any of that stuff. So what do? Well, it just simply means that I'm just going to plug in the infinity, and we're just going to get rid of all the ones that we just consider to be unnecessary. So what is the one net part that's unnecessary? Well, quite frankly, if we were plugging in the infinity here, this plus 25 is garbage. This minus 3 is garbage. So what really comes down to is, it's that. The plus 25 square root, that doesn't really do anything for the question because we're plugging in such a huge number for x that this 25 is completely negligible. So I'm just going to consider the one that actually matters. Now what I'm going to do is I'm going to plug in infinity at the top. And what happens if I do 4x squared and use the square root of that? Well, that simply makes it 2x. Before I plug in the infinity sign, I'm just going to leave it as x on the top. Square root of 4x squared is simply 2x. Okay? Now that I simplify it and it looks like this, what happens to the x's here and here? They cancel each other out. So what I end up with is 1/2. So the limit as x approaches this as infinity sign will give you 1/2 in total. Now, if you were to graph this on a graphing calculator, what you're going to end up getting is that as you approach the positive end, the y value, okay, so if that's 1, that's 2, the y value will tend to be somewhere in 1/2. So if you keep on making this, window to be like, 10,000 or something, you will see how the y value will come out to be somewhere around 1/2. If I had the graphing calculator, I could show it to you, but unfortunately I can't do that. But if you guys were to type that in your calculator, you should be able to see how the graph also comes into the picture. Before you do this again, let me just use Desmos to show you what I'm talking about. So I'm on the Desmos right now, and I am going to just simply type in the x minus 3 over square root of 4x squared plus 25. Now, if you were to graph that on Desmos or whatever that you guys do, I have a graph that looks something like this. Okay? So if you take a look at this graph here, notice how this graph, if you guys were to zoom in, there will be a boundary in which this graph will approach to, and that I can guarantee you it's 1/2. So that's how you also know that the limit is approaching 1/2. Hopefully this video helped, and if you guys have any questions about calculus and limits and those kind of things, they are all falling right in them under my forte. So please don't be shy. Feel free to ask me any questions. Thank you and have a good day.